Have you ever found yourself tangled in a web of code, trying to optimize your functions but feeling stuck? If that sounds like you, you're in the right place. Today, we're diving into the world of tail recursion and mutually recursive functions. I totally get it. Trying to optimize code can be a real challenge, especially when you're not sure if you're on the right track. You're definitely not alone in this struggle. Many developers face similar hurdles when dealing with recursion. Let's take a look at the specific question at hand. One user asked, "How can I make my mutually recursive functions tail recursive for optimization?" They provided some code and attempted a few solutions. Sound familiar? Let's break it down together. So, what's the issue with the original code? The problem lies in the fact that the functions are not tail recursive, which can lead to Stack Overflow errors for large inputs. Understanding this is crucial for optimizing your code effectively. And stick around. I'll share the correct solution at the end that will not only optimize your functions, but also enhance your coding skills. To optimize the mutually recursive functions, the user should first understand that tail recursion requires the recursive call to be the last operation in the function. Let's start by examining the first attempt at tail recursion. In the user's first attempt, the recursive calls to functions gt and ft are not in the tail position because they are followed by string concatenation. This means they cannot be optimized by the compiler. Next, the user provided a second attempt where they introduced an accumulator parameter. This is a step in the right direction, as it allows the function to build the result without needing to concatenate after the recursive call. Finally, the user arrived at the correct solution. In this version, the recursive calls to fa and ga are indeed in the tail position, allowing for proper optimization. Fun fact: did you know that the concept of recursion dates back to ancient mathematics? It's fascinating how these principles have evolved into the programming techniques we use today. Now, let's look at the answers provided by other users. This user points out that the original attempt does not place the recursion in tail position. They suggest using continuations to achieve this. By implementing helper functions fk and gk with a continuation parameter, the original functions f and g can be redefined to utilize these helpers. The user provides a JavaScript example to illustrate their approach, noting that the syntax is similar to F#. This allows for easy testing in a browser, demonstrating how the functions work with various inputs. Here's a pro tip: always use accumulators in recursive functions when possible. This simple technique can save you from potential Stack Overflow issues and improve performance significantly. And there you have it. You now have a better understanding of tail recursion in mutually recursive functions. Remember, optimizing your code is a journey. If you found this video helpful, don't forget to subscribe for more coding tips and tricks.